So, what is time complexity and why do we need it? Well, time complexity basically describes the amount of time it takes to run an algorithm. Because how do we decide what algorithm is better? Well, we can either look at how much space it consumes, then we would look at space complexity, so basically how much space in memory algorithm needs, but mostly we don't care about that. Mostly we care about time. So obviously, faster algorithm is better. Now, how is it computed? Well, the one thing you can do in order to measure efficiency of algorithm is to simply start stopwatch at the beginning of algorithm and then end the stopwatch and you have your time, right? So would this work? Well, no. There are a couple of things that will change your value. For example, if I run the algorithm on my laptop and FBI runs the same algorithm on their supercomputer, we would get different results, right? I know this is extreme case, but I hope this makes sense. The device on which you run your algorithm matters, but also the size of input matters, right? Imagine that I have a function that will sum up all the numbers in an array. But obviously, if you call this function with 10 elements, you will get smaller time than when you call this function with 10,000 elements. So the input length also matters. So the approach of measuring time just doesn't work. What we need is some way of representing a complexity, and it should be able to take the size of input into consideration, and it should also get rid of the difference between devices. So, we need a bit more mathematical approach. We need function. And what this function does? Well, it takes the length of input as a argument and it returns a number of operations. But what do I mean by number of operations? Well, it is just basically every operation you do. For example, the assignment operation, the plus operation, the compare operation, and so on and so on. So, for example, if I have here this algorithm, you can compute the time complexity like this. On first line, you can see assignment operation. So that is 1. Then, in the for loop, we initialize I to 0. So that is 2. Then, we repeat these 4 instructions. First one is that we check whether I is smaller than n. Second one is this plus operation. Third one is this assignment operation. And last one is this increment operation. So these are 4 instructions that we do n times, right? Because we do this while I is smaller than n. So the time complexity of this algorithm is 4n plus 2. Plus 2 because we have 2 assignment operation, one here and second here, and these are happening only once, no matter what the length of input is. And then there are these 4 instructions, and these are happening n times each. So if the input length is 10, we get 42. If the input length is 100, we get 402. Because the overall time complexity is 4n plus 2. Now, I want to leave with a little bit of teaser for next lecture. Imagine that I have this code. So, the only difference is that now the plus and assignment is in one operation, right? So, is the complexity of this 3n plus 2 or it stays 4n plus 2? And the answer may surprise you a bit. It pretty much doesn't matter. But I will talk more about that in following lectures. And with that being said, if you have any questions, feel free to ask, and I will see you next time.